In this question, it is given that disk which is rolling purely and after striking with this step, it does not bounce and it does not slip also. So in order to climb the step, we need u greater than u1 and for disk not to bounce, u less than u2. For so first of all, let's find angular velocity of disk about this point after striking the strap, and then we will calculate value of u1 and u2. Initially this disk is moving with speed u towards the strap and angular velocity omega, and just after striking the strap, let's assume that its angular velocity, as disk will now rotate about this point p, this rotate, so this point p will act like hinge because disk is not slipping about this point p. So we can assume pure rotation about P just after striking the step. So we can conserve angular momentum about this point P. Angular momentum about point P will be conserved. So initial angular momentum will be mu into perpendicular distance, that will be r minus r by 6, 5r by 6, plus angular momentum due to rotation I omega mr square by 2 into omega, and omega is u by r, equal to final angular momentum can be written as, assuming pure rolling about p. So let's assume its angular velocity just after striking is omega naught, and that can be written as I about this point p, that will be 3 by 2 mr square into omega naught. So from here we will get value of omega naught as 8u upon 9r. Now in order to climb this disk over this step, what should be minimum value of omega naught? So minimum value of omega naught should be such that it just climb over this step. If it climbs over this step, then its potential energy will increase and kinetic energy will decrease. When this has just step up on this step, its center of mass has moved r by 6 in vertical direction. So work of, or we can use work energy theorem, work of gravity will be minus mgh equal to change in kinetic. So if we are calculating minimum angular velocity omega naught, in that case its final angular velocity will be just 0. So final kinetic energy 0 minus initial kinetic energy half m omega naught is half I omega naught square, 3 by 2 mr square into omega naught square, and omega naught is 8u by 9r, but u is u1 according to question. So from here we will get value of u1, and that value of u1 will be under root 9g r upon 32. 9gr upon 32. After substituting values, this will be 3 by 2, 1.5 meter per second. Now let's calculate u2. In this question, it is also given that this speed u should be less than u2 for disk not to bounce. If disk does not bounce, then it means normal always should be greater than 0. So suppose at a particular instant this disk has left contact with ground and this line is making angle theta. So force acting on its center of mass will be mg, and let's assume this angle is theta, and normal force on it will be like this, and acceleration of center of mass will be omega square r, and let's assume angular velocity at this instant is omega. So net force towards center will be mg cos theta, this is some intermediate stage, minus n, that will be m omega square r. So normal, general value of normal as a function of theta is mg cos theta minus m omega square r. So if disk does not bounce, then it means all values of normal should be greater than 0. That means minimum value of normal should be greater than 0. If minimum value is greater than 0, then obviously all values will be greater than 0. So minimum normal will be when omega is maximum. Normal will be minimum when mg cos theta is minimum and m omega square r is maximum. So students, cos theta will be minimum when theta is maximum, and that is only at the initial instant just after collision with the step. I mean when this disc strikes with the step, at that moment cos theta will be minimum and theta will be maximum. And what will be value of theta? At that moment theta will be maximum. That will be cos theta will be base upon hypotenuse. So base is 5r by 6, hypotenuse is r. So cos theta, minimum value of cos theta is 5r by 6 upon r, 5 by 6. When this disc moves up this step, then this value of cos theta will increase because theta will decrease. So this is minimum value of cos theta, minimum value. And what will be maximum value of omega? Maximum value of omega will be just after, will be when it just strikes the step, because as this disc moves up the step, its angular velocity will continuously decrease. So omega maximum will be initial angular velocity omega naught. So minimum value of normal we will get, minimum value of normal will be mg cos theta is 5 by 6 minus m omega naught square into r, and that should be greater than 0. And value of omega naught is, we calculated earlier, 8u by 9r, 8u by 9r, 5 mg by 6 minus m 8u by 9r. In that case u is u2 into r, that should be greater than 0. So from here we will get value of u2, and that will come out to be greater than or less than omega, u2 will come out to be less than under root of 15 into 3 by 4, and that will be 2.91 meter per second. So maximum value of u, I mean u2, maximum value of u, which is u2, that will be equal to 2.91 meter per second. So we have calculated value of u1 and u2. Now you can answer PQR. And for S, horizontal component of impulse that disk experiences, that can be calculated using impulse momentum theorem. Impulse is equal to change in momentum in x direction, because we are asked about x component of impulse, that will be m into final momentum, final velocity of center of mass in x direction, and that will be omega naught. Omega naught is the angular velocity just after collision, so its velocity will be omega naught r, and its component in x direction, and that will be theta, 90 minus theta, omega naught r cos theta. Velocity of center of mass in x direction will be omega naught r cos theta, minus initial velocity in x direction is obviously u. So from here we can find x component of impulse. Thank you.